said, welcome. Thank you all for coming. I'm Bec, this is Jess and Chloe. We are the former leads of Nova Rover. And our team, Nova Rover, is an engineering team based at Monash University. We're made up of 100 undergrad students, mostly from engineering, also from science, IT, commerce, design backgrounds. So we are multidisciplinary, and our goal is to create planetary rovers which have the aim of going to competitions around the world. These are our rovers that you've never seen before, and they have lovely names based off Australian animals. And we started with a group of just 4 students. They created this first little rover on the left that was for part of their course at Monash Uni, and they decided we work so well together, we want to do something more, and they found the University Rover Challenge, an international competition that they wanted to compete at. So that has spurred the creation of the next 5 rovers, which have grown in size and complexity, and our team has grown alongside those rovers to be at 100 students. Yeah. So going on to our challenges, what do we build these rovers for? We have 2 fairly similar competitions. The first is the Australian Rover Challenge. This one was actually started by 2 of our alumni, which is pretty exciting. They started it back in 2021. It is held at around Adelaide, and it's held basically to simulate the lunar environment, and it sees 8 maximum. We've had is 8 teams compete at this competition, and the rover has to do 4 tasks based on a lunar landing. So the first task, it has to find its way around the area and sort of see if there's anything going on with the moon. That's probably my phone because no one's fixing it. Classic. Yeah, it's pink. Thanks. Yes, that's my brother who would have no idea I'm doing this tonight. Anyway, feed the dog probably was what he wanted to know. So we had these 4 tasks. One of them is about looking around the lunar surface to see if there's anything going on, and they will use the robotic arm that we have to service equipment. Then we have an autonomous task where we have to path plan and find our way over the obstacles on the lunar surface. We have a scientific task based on finding and extracting water off of the lunar surface. And finally, a construction task all about setting up that lunar base, where we have to excavate regolith and clear debris and things like that, and create a road on the terrain. Yeah. So the other competition is the University Rover Challenge, which is the international one. It sees 100 teams enter each year, and the top 36 teams are invited to go. So we are the sole Australian team to ever make it into the finals, and we have been quite a few times, and we have made the podium the past 2 years in a row, which is really exciting. So held our ground at 2nd place, which is a huge testament to the team, and it's a huge process to go to this competition. So we took 30 students, around 30 both years, and we stay out in a very rural little town. We put all of our stuff, our rover, into suitcases, get it over there, put it back together, spend 4 or 5 sleepless days of testing non-stop, and we take it to the competition and hope for the best. And so we have this highly trained group that are the operators on the day and in charge of all these little bits and pieces with the rover. And again, there's 4 tasks at this competition. This one is a Mars-based competition, so there's slightly different objectives. For example, the science task is based on looking for life in samples, and that changes the whole way that we make up that payload. Then there is some other more extreme challenges. Of course, we are in this amazing desert environment over there, the Mars Desert Research Station, and one of the tasks we have to cover a kilometre radius of the ground, so we have to go over this rough terrain, make sure that our radio signals and comms stay working the whole time, and really push the limits of our rover to get up really steep terrain, pick up heavy objects, and simulate, helping astronauts that are stranded over there. So it's a bit of fun. Yeah. We are also very privileged in our team to have had amazing connections with the space sector on many occasions. So the Australian Space Agency has been a great support to us, and also we have partnered with Gilmour Space in their trip to NASA, where we went to Kennedy Space Center to test the geomechanics of our rover in their Lunar Regolith Test bin, which is where the Apollo astronauts trained for moonwalking. So that was super surreal. That's some dusty photos of it there. We've also been to 2 other NASA sites, namely the Jet Propulsion Lab in California, where we saw the Optimism rover, which is the clone of Perseverance. And we also got to see the Viper rover at Ames. So we have had these really amazing collaborative experiences, and it just opens our eyes up as students to what is out there in other countries, and really inspires us to go, if we are on the world stage and second best in the world as this, small group of Aussies, then what can we do in Australia to build up the space sector, because we are at the forefront of it already. Yeah. Beautiful. Some formatting issues, but anyway, we have also, at the heart of our team is the spirit and camaraderie. We are all about having a bit of fun, and it's all about the individual's growth. So the rover's performance is not the main goal. It is all about everyone coming out of the team with new skills, with new friends, and with a newfound confidence and passion for the space and STEM industries. So we essentially focus on that, and focus on how can we make things a bit more fun, and how can we build up and create a bigger team. We've actually just taken on 47 new recruits to our team last week, so we've got a lot of work to do in the next months. Yeah, beautiful. I will hand over to Jess.
Thanks, Bec. Hi, everyone. I'm Jess. I'm just going to give a little brief overview of the internal makeup of our team, what it kind of looks like day to day when we're working on the rover, and a little bit about our actual rover systems. So hopefully it'll just be like a brief overview of our most recent rover that we've been developing from mid-2022 for competition at ARC and URC in 2023. And so that's our pink rover Waratah. So firstly, within the team, we are made up of a few different sub-teams. So we have 5 technical sub-teams and 1 non-technical sub-team. So we've got our business and media team who do all of our social media, and they get sponsors for us, which is super important when when we need to build this rover. We actually need to be able to pay for it. So that's they do a great job with that. And then we have 5 technical sub-teams. So obviously the rover is a very complicated system. It's made up of a lot of different subsystems and subcomponents. So we break that up into different sub-teams and have specialized groups of people working on the different subsystems. So we have the electrical team, software and autonomous, and the chassis team working on sort of the core rover systems, getting the rover to actually drive and the core components that we need for every single task that we compete in. And then we also have a few payload teams. So the robotic arm team, the science team, also the autonomous team, they work really, on the specialized payloads that we need for certain tasks. I'll go into a little bit more technical detail. So firstly, of our core rover systems, one of our main goals for the 2022-2023 design cycle was really just to innovate and come up with crazy new ideas and see what we could do, because we performed very well in the 2022 competition, coming second, but we didn't want to be, complacent with what we designed. I mean, the rover that we took to URC in 2022 was by far the most technically complex thing we've made, but we didn't want to let that stop us from, trying new things. So we pretty much entirely overhauled the core rover systems. We made a new chassis body, new suspension. We went from a 6-wheeled skid steering system to 4-wheel pivot steering, which basically gave the rover a lot greater maneuverability and also reduced turning scrub that we had a lot of issues with in our previous design. We also switched from brushed motors to brushless motors, and we had members in the team developing custom brushless motor drivers for this as well. And yeah, that we really saw the rover, I guess, go to a higher level with that. We were basically able to traverse a lot more difficult terrain than we were able to do previously. To accommodate this, we made a new LiPo battery unit. We had new, bigger, wider wheels for increased traction, and with an internal bike spoke geometry that you can see there, basically to reduce the weight. So a lot of the requirements for the rover design are centered around weight and also cost. So we have to adhere to a strict monetary budget, but also weight budget. So to do that, yeah, we really try and optimize on weight. And for cost, we make a lot of our components in-house. So yeah, we have a huge number of people in the team trained up to use CNCs, manual machines like lathes and mills, and yeah, basically manufacture all of our parts ourselves where we can. In terms of the core electrical system, it's a modular backplane system. So we have daughter boards, which we call Nova cards, that can plug in and plug out of the backplane, and a custom Jetson carrier board as well for our Jetson TX2, which is the brains of the rover. So yeah, basically everything that we have on the rover also has to be controlled from a remote base station. So everything's done via radio communications. And yeah, I guess this kind of leads in to the next thing I'm going to talk about, which is our payloads. So that was our core rover systems that basically feature in every task. Now we've got a few payloads that we sort of switch in and switch out on the rover. So firstly is our robotic arm. So this is a 6 degree of freedom robotic arm, which features 6 custom cycloidal gearboxes. One of the big focuses of the arm is the operability. So as you can probably see in the background, and as Bec kind of touched on some of the tasks we have to compete in, we need to be able to basically interact with this equipment servicing module. So flicking switches, pulling out drawers, moving joysticks, taking out a USB and inserting it in a tiny USB slot. And all of this is very difficult when you're doing it with a robotic arm and only with, you know, what you're getting from the onboard cameras on the rover. So you can see a picture over there of the base station. Basically, the operators have to rely entirely on the feedback that's coming from the cameras or the motor controllers to sort of know what's going on. So that's a big part of what we do, is operator training and getting people trained up to actually, I guess, compete in the competitions. I guess some of the things I haven't touched on, we use brushed motors for the arm, but we're hoping this year to sort of revamp and start again, make an entirely new arm, again using brushless motors and custom motor drivers. And we have custom magnetic encoders for velocity control and absolute encoders for position control. So that allows us to use inverse kinematics, which makes it super much more intuitive for operators to actually control this thing by telling it to go forwards, left, and right, rather than having to control every single joint individually, which from experience I can say is very not intuitive at all. Yeah, next slide. So the next payloads we have are the science payloads. So we have 2 science payloads, one for the Australian Rover Challenge and one for the University Rover Challenge. So as Bec mentioned, they're 2 very different tasks. At URC, we're looking at life detection. So you can see one of our URC payloads down there. It's basically got a platform that can lower to the ground, has a microscope on it for looking at rocks. It has metal scoops that can extract samples from the different sites, and these samples can basically get pumped through a custom paraceltic pump system and delivered to a spectral carousel, which has a bunch of chemical assays in it for analysis. On the ARC side, we're looking for water detection and extraction. So in this challenge, we are going to the different sample sites using an auger drill to excavate small samples and basically depositing those samples into small kilns, heating them up, looking for the greatest mass change and identifying which sample has the highest water concentration. Then we can go ahead and excavate more from that sample site and try and get as much water out as possible, basically. Yeah, next slide. And finally, we have our autonomous package. So again, two slightly different tasks in the ARC and the URC competitions. So for ARC, the rover basically has to autonomously investigate a previously unseen area. So it has to go out and basically identify AR tags, colored bricks, random terrain features, and then determine the location of these features, and it has to do that entirely autonomously. Whereas for URC, it's a bit different. We are navigating to set GPS coordinates. Some of the GPS coordinates they give us slightly off. They try and throw us off a bit because we're actually trying to navigate to some AR tags. So it's basically navigating to a GPS coordinate and then trying to find the AR tag in the vicinity and get within a certain distance of those tags. So for this, we use differential GPS, but this year we actually use 2 differential GPSs, which means we not only get centimetre accurate positioning, but we also get a very accurate heading and pitch for the rover as well. Yeah, that's all from me. I'll pass over to Chloe.
Thank you, Jess. Yeah, so you might have been thinking, love the pink, but why the pink? But there's actually a very strong intentional reason why we decided to paint our rover pink, and that was to start conversations about women in STEM. It's that pairing with pink and engineering, which is sort of a contrast in stereotypes that sort of makes you think a little bit, hopefully, about the industry and sort of the perceptions around STEM and how that's actually affecting our workforces. So these are the scary statistics that you might or might not already know, but 36% of enrollments into STEM degrees are women, and 14% of our workforce in engineering are women as well. So the underrepresentation and lack of relatable role models affects students and workforces in STEM. What we want to try to do is attract women to STEM, but also retain them. This is a barrier that socially positions STEM to be perceived by some young women as intimidating and alien. But it's not to me, and it's definitely not to us. There is a stark contrast between the societal cues that are provided to young boys and young girls. According to the Australian Department of Education, girls are directed to teaching, nursing and beauty, boys engineering, information technology and science. So this is a reflection of the gender coding that permeates our society and negative stereotypes that serve to discourage women into STEM. Now, given this correlation between early attitudes towards careers and subsequent career choices, we absolutely must give young women the equal opportunity to discover and learn STEM. Cool. However, for the women and girls who do make it into STEM and break through all of these barriers and bias, they face a lot of discrimination and gendered expectations, which can make it difficult for them to succeed and stay in STEM. So the STEM workforce is losing talent. We are currently not accessing our full STEM potential around the world and Australia. So it's so important that we create inclusive and equitable environments that give everyone a sense of belonging and welcoming. Cool. So thank you for the clap. These are the 3 missions. So this is what our team is doing. So first, empowering through education. We have a wealth of knowledge and we're really passionate about starting the next generation workforce. And that's our team going through university, creating these amazing rovers and then going out into the space industry and creating a strong, sustainable domestic industry in Australia. But we're also, part of this pipeline and we think about the people coming before us. So we've created a plethora of outreach programs that target different demographics and ages. So we have tailored some of our outreach programs specifically for women in STEM. So we provide those women role models running those classes, and sometimes we have all girl classes, and we have seen the difference in participation. So that's empowering through education. Every chance that you get to give an equal opportunity for another girl to discover STEM is what we're trying to do. Second is bringing visibility and fostering engagement. There's a lot of talented women in STEM, and I think we need to be seeing them more. I like to say that we need more STEM celebrities. Like, I love Doja Cat and Ariana Grande, but what about Catherine Bonnell Pegg and Pamela Melroy? So
we try to highlight the talented women in our team. We've got 30% women. We had 50% of our technical leads were women as well. And just trying to push out photos of our women actually doing engineering, actually doing hands-on work. As you can see, our electrical lead, 4 a.m. at night before the day of the competition, fixing our science payload. And then we foster engagement as well through events. We had a 300-person event for our launch night to launch the first conversation around Pink Rover and Women in STEM. And we also had our Women in STEM panel night where we invited 11 women from the industry to talk about their experiences and also their experts. And we learnt really cool stuff about space and robotics. And our third mission is addressing barriers and bias in STEM. It does start with an individual level and reflecting and understanding your own unconscious biases. I have internalized misogyny and I have toxic masculinity, but I think it's addressing them, being aware of them, and how, the adversities people have around you so we can all be inclusive and equitable. This is the impact so far. We have, reached over 2,000 kids. We've met with a lot of government officials. We've talked with a lot of businesses, and we've really amplified the conversation in our community. So I guess today is just another one of those events. I encourage you guys to talk about Pink Rover in your workplace with your friends and family, and hopefully we can raise awareness and get that 14 up to 50 one day, soon, next year. Counting on you. Well, thank you so much for listening to our talk. Keep up with us on social media. We're definitely doing a lot of stuff this year. We've got our new leadership team, and they're taking the team to new heights. Thank you for listening.
We've probably got time for a couple of questions.
It's essentially okay, I'm not going to be doing a very good job of explaining this, but the internals of the motor are different when you compare brushed and brushless. And basically with brushless, you get increased efficiency, better torque to weight ratio. Yeah. It's better, yeah.
So that was BP1 simulant, and it's a mechanical simulant, and they actually got it from some mining site. So I think there's only like one sort of, like, you can't make it again. It was like the byproduct of some mining operation. But yeah, it's a well known and used mechanical simulant, and you can trust the geomechanical properties. But then there are also different simulants that are like chemical, and yeah.
Well, we are at a university, and that's tricky. But yeah, we have been reached out to by a few companies to make commercial products for them. And yeah, it's just the stepping stone of, do we want to branch off and make a little Nova startup that can do that quite freely with full autonomy? Or do we try to go through this university system? So the university has great programs. One of the things that we do, all of us as undergrads at Monash, you get your honours year in engineering, and in that honours year you have to do a final year project, which some of us are suffering through right now. So lots of the work where you can do a research project, and a lot of team members have done that project with Nova to do something related to our rover that may end up on the rover too, and it's also viable research that is useful in the industry. So there are certainly avenues, but it's I guess how do we want to go about it is sort of the question at the moment. And for now, building up these undergrads to finish their degree and go into companies like Lunar Outpost, building that Lunar Rover, or going to various companies that everyone here is all pretty much everyone here has a part-time job in an engineering company. So there's all those skills being brought into the industry from the students. But this is a safe place to play and to throw money at brushless motors and go, whoops, that didn't work. We'll try something else next year. So it's a little bit lower risk than a startup, which is where it has its sort of beauty, I think. Yeah.
So we have small rainbow robotic rover kits, and they come like disassembled, and so you do the mechanical assembly, and then you have like a breadboard, which I feel like is like the first thing you kind of want to be introduced to if you want to do electrical engineering or mechatronics. And then we have like a bit of a wired diagram with an Arduino, and we wire it up, and then once they've finished building that, they can put it down, and the kids love this, and they race their rovers and they try and make it heavier so it goes faster, or put rubber bands on their wheels so it got better traction. But yeah, and I think that's really a great introduction to engineering, and that's what we want.
Okay, well, thank you so much for that. That was amazing. Round of applause. Thank you.